The Gasworks Pecketts have been coming on slowly and gently. I still have no wheels, but I have everything else, and I've made nearly every component for them now. The one we're looking at the moment is the one that I hope is going to a customer, and it's due for painting by somebody else, which is why it's missing its fixtures and fittings. But nonetheless, it's very well progressed. These models I'm actually very pleased with. They've come out very nicely indeed. This one is in grey primer, as you can see. To go back a bit, these models, Harrogate Gasworks Peckett, 3D printed, and they've been it's been drawn up in Design Spark Mechanical. Now, Design Spark Mechanical is a 3D drawing program, and it's a free program downloaded from RS. That's the electronics component company, and different drawing programs have different strengths and different weaknesses. This one, it's a little bit like SolidWorks, I think, in the way you draw. It certainly suits me very well, and I set myself to learn it, and it took a while. It always does. I'm very fluent with 2D drawing on a computer, but 3D is an entirely different approach as to how you actually construct a drawing and how you manipulate a drawing. It's very, very different. So I was starting from the very basic level, to put it mildly. And I've been doing this as an exercise in how to draw effectively in 3D, and very valuable it's been. Now, my approach has perhaps been slightly different than many people, insofar as I have tried to draw it pretty accurately as per full size, i.e. if a tank wrapper is expected to be out of 1/4 inch plate, for instance, then that is the thickness I've drawn it. If we've got angle, let me zoom in, at the foot of there, then I give it the proper profile of angle, rather than simply a chunky right angle there and right angle there and all the rest. So I've endeavoured to be as real as possible. Now, the eagle-eyed amongst you will notice this. Now, this is where I've had to deviate, and this is interesting. This is a rivet. Now, of course, I can draw, and did draw, proper dome head rivets. And this is where I came unstuck. As soon as I populated this drawing with rivets, proper rivets, dome heads, as we all know and love, then the drawing became massively unstable because of the amount of data. And if you think about a sphere or a hemisphere and think in terms of the number of facets that is on a sphere or hemisphere, and think how a computer might struggle with the number of facets on a body like a sphere. A computer can struggle with a great deal of those, and so it was this program suddenly became overburdened and took up a massive amount of memory, and struggled and started to fall over, with all the rivets being proper genuine dome head rivets. So I substituted all the rivets for these discs that you that I showed you, and I've got away with it because as soon as you start painting them, the paint sort of fills the gap and rounds everything off, and in visual purposes it becomes domed, because you have to remember this is actually very small. It's about 0.3 of a millimetre, so it's very small, and although this is what the plastic is doing, because it's painted, that smooths over into a dome very nicely. So all the rivets are these discs, but wherever there should be a bolt head, for instance, they are proper hex head, as it should be, and that's fine, that's no problem. So you can see we have hexes where we need them and all the rest. So that's really been the only compromise I've deliberately made. Also, I've taken the risk of putting, let's say, vulnerable detail on the drawing to print out, like this lamp iron. And I've done that because it's going to be very difficult, sorry, I'll stop flipping about, very difficult to get something as detailed as this and as shapely, as correctly shaped as this, any other way. You can see the top is properly profiled and it's held on with hex bolts there. And I've taken this risk because the resin I'm using is the engineering-like resin from Iono, and it's actually got a very nice flexibility to it. So if it gets pinged by accident, it'll bend a bit rather than break. So hence me putting on detail like that, which common sense would otherwise tell you would be too vulnerable and really not a good idea. Similarly, if I spin round, spin a bit more, you can have a look at the detail on the hinge, and you can see, I hope, that the hinge detail is drawn again as if it's a real hinge, as opposed to, let's say, a crude caricature. Now, in fairness, it takes a lot longer to draw to this level of detail. For me, it's a learning exercise, but it is also something of a record of what I find with this Loco. So as long as the computer doesn't corrupt the program, and as long as it's kept, I have this 3D record of the thing, and I can sort of say, well, you know, this is how I believe it is, and I can do I can effectively do what I will with this shape. So I've been drawing all that up. Other aspects of it I've been drawing. Now, the back head of the Loco. This particular Loco, of course, it's hard to see the back head because, of course, the cab is uniquely low. It's not got a lot of ways you can see into the cab, so it's not easy to see very much. However, that's not going to stop me from modelling it. And while we've got the computer out and the printer out, we'll try and do our best to make a nice job of it. So what we have here are my take on gauge glasses. Now, gauge glasses are the boiler water level indicators, and these sprues here go into the boiler, and the water and steam is allowed into the gauge glass here, steam in the top, hopefully, and there's a shut-off cock here, and water into the bottom one, a shut-off cock here, and then the glass sits between them, and the level of the water in the glass is a true reflection, one hopes, of the level of water in the boiler. And then this one here is a drain cock for the gauge glass, allowing you to drain it down and double check the level in the gauge glass. Now, of course, we normally just see metal castings and you paint this bit white or what have you. Because we're printing this anyway, I thought it would be fun to do something a little bit different. So what we've done with this is print these rather strange things. Now, what we're representing here is the cocks, top and bottom, and then this section here, you have the glass tube normally, and then the gauge glass protector. Now, the gauge glass protector has the frame, which is brass or gunmetal, and you have a top plate and a bottom plate, and then in fact you have brass rods, one on each corner, which hold the top and bottom plate apart, and then you just have a sheet metal back plate, and that back plate is painted, and it's painted with normally black and white stripes, and that contrasts the water when it appears in the glass, and in fact, due to refraction, it reverses the image so you can clearly see where the water level is. So if we paint this section, in black and white stripes, that will give a very nice rendition of the gauge glass back plate. And then all we have to do is get a little bit of perspex, clear perspex, and cut it into a block that size and glue it into this space here. And that's what we've done, or that's what I've done. So I've printed a pair of gauge glasses there, and let's have a look. Have a look at the Loco. Let me pull it apart, and if I take the backhead out. Swing it, and let's hope you will be able to see. Don't know if you can see properly. But there we have our gauge glasses with perspex in them, and that's what that's about. And they're printed with a block of perspex just sat in there, well, glued in there. I say sat in there, glued in there. And the backhead itself is all printed in one piece, but all the extras, like the firebox door linkage, that's a separate element. The regulator's a separate element, and this is all printed. And the reverser is a print, and we also have the manifold that's a print. Let's see if I can zoom in on the manifold successfully. That's all 3D printed, and the wheels are part of that same print. The pipes that go up to it are not. They are brass, nickel, silver, what have you, just painted to match. But you'll notice there are hex gland nuts and things represented on there as well. So that's what I've done with the backhead, and we can have a look at that. I think let me beg pardon. Yeah, that's the manifold drawing. You can see what we've got there. Took a couple of hours to draw that up, but it's not rocket science to do. The trick, if you like, is in the resin, which I say again is the Iono engineering-like resin. This is actually printed in the grey resin, and in the settings, and I've used the finest settings possible to do this, but it comes out all right. I think I have some still. Yes, I have some still on the sprue. So you can see what I'm talking about. Oops. So they come out very well. And at that point, it's just a paint job to tart them up properly. So that's kind of the design side on that. Design Spark Mechanical, used and abused to produce a Loco. It's one of those things. The more you practice, the more you can do with it. There isn't a shortcut. There isn't a magic button. You just have to get down and have a play. And there's lots of tutorials on YouTube as to how to do specific tasks, which I've found invaluable, and I heartily recommend. That's how I learnt how to do all sorts of various things, and then just set about doing it. So that's where we are with those. Now, my Loco, the one I'm keeping, has progressed to this. it's almost fully painted. It'll get an additional spray of soot over the top later on. Still no wheels, as we've said already. Crossheads and things are made. What have I done with the box of bits? I put them somewhere. Yeah, here we are. Box of bits. Lost them. Where are we? Yes. Oh dear, throwing things on the floor. Crossheads are CNC'd out of sheet nickel silver. There's 3 pieces forming the thickness of the thing, and then, oops, Daisy, confusing the camera, and then the piston rod and the sleeve at the end of the rod. So it took a while to make those, but they've come up quite nicely, and the nut will trim off when we're done with that. I tend to make them open back, so there's so the bolt that pokes through is silver soldered into the con rod, if that makes sense. That's how I choose to do it, and those will just slide on. Let me turn that round. We also have, let me zoom in, we have the lubricator there, and the first part of the lubricator drive is there, and that will